So let's take a look at synthetic division. Synthetic division is basically a shorthand for doing the long division. But here's a couple of things that are extremely important. First thing, the numerator is what would go underneath the division symbol, correct? And you're like, what division symbol? This division symbol. The numerator goes under here, correct? Well, not only do you need to make certain that this numerator is in descending order, you cannot have any missing x's. You can't have any missing powers. If this was missing an x squared, you have to fill it in with the 0. With me? You can't have any missing powers with synthetic division. Got it? The second important fact with synthetic division is what you're dividing by. You know, the x plus 5 would go out here, correct? What you're dividing by must be linear. It must be linear. That's important. Synthetic division can only divide by a linear polynomial. And you're like, what's linear mean again? That x needs to be to the power of 1. That's linear. If it's not linear, you're not going to be able to do this. Are you with me? Okay, those are two extremely important pieces of information. The polynomial you're dividing by, which in this case is the numerator, must not only be in descending order, it can't have any missing powers. The second important fact is that what you're dividing by, this denominator, has got to be linear. It's got to be to the power of 1. My recommendation is you pause this video and rewind it and write those two pieces of information down and then continue. I'll wait. Okay, you're back. So here we go. Now, this is the long division, right? That's the long division symbol that we use. Synthetic division looks like this. You're like, that's weird. I know. Now, I need you to think of synthetic division as long division without variables. So no variables. That's why it's kind of a shorthand. So, the numerator would have gone underneath, correct? Well, this is where my numerator goes. This is what I'm dividing into. Right here, it's this line right here. Now, I don't care about the variables, or I should say synthetic division doesn't care about the variables, which means, since that's a 1, I'm going to write the 1, the coefficient of x cubed, the 6, the coefficient of x squared, the 4, the coefficient of x, and then the minus 7, which is that constant. With me? Okay. Now, let me pause a moment. The reason why it's important for you to put in a 0 if it was missing a power is this. Synthetic division reads from right to left. So, synthetic division would see the negative 7 as the constant. It would see this as the x to the first, this is the x to the second, this is the x to the third. Which is why if it's missing one of those powers, you better put the 0 in, because it doesn't know that. The process doesn't know that. It automatically thinks that everything is in the correct order. Constant, power of 1, power of second, power of 3. Got it? Okay. Now, this x plus 5 is what goes on the outside, doesn't it? Now here's the deal. The x plus 5 can't go on the outside here because I can't have the x's. And you can't put a 1 and a 5. That looks really weird. It makes 6. So, the synthetic division process is this. When I'm trying to put the x plus 5 on the outside, I'm going to take care of two birds with one stone, so to speak. I'm going to take x plus 5, and I'm going to set it equal to 0, and I'm going to solve for x, which gives me negative 5. X would be equal to negative 5 in this case, which is what's going on the outside, is the -5. Here's what I mean now with two birds with one stone. So watch. We have the setup, the coefficients, and then what's on the outside is this linear being set to equal to 0 and putting what x equals on the outside. Got it? Okay. Now, synthetic division always starts the same way. This 1 always comes down. Or I should say this first number always drops. Always. This area is your answer spot, which is the same thing that was up here, right? So, remember with long division, once you put a number on the answer spot, you multiplied by what was on the outside, didn't you? This is the same thing. When I put a number in the answer spot, I'm going to multiply by what's on the outside. So I'm going to do 1 times -5, which is -5. And I'm going to put it under the next number in line, which is the 6. Got it? Okay. Now, in long division, you put the number up top, you multiply by the outside, you put it under the correct term, and then you subtract. Well, here's the two birds with one stone. This was a +5, but then it became a -5 when I set it equal to 0. Are you with me? I don't have to subtract, because as soon as I set it equal to 0, the 5 changed signs. So it took care of the subtraction part, which means all I have to do is 6 plus a -5, which is +1. I don't have to subtract, I just add the two numbers together. Do you notice there's still a couple numbers? I start all over again. The number I put in the answer spot gets multiplied by the number on the outside. So 1 times -5 is -5. Where do I put it? Under the next number in line, which is the 4. Then what do? I simply add, because this 5 changing signs already took care of the subtraction that I had to do over here in long division. So 4 plus -5 is, good, -1. Am I done yet? You're right, I'm not, because I still have this next number, so I have to start over again. So I take the number down here that's in the answer spot, the -1, and I multiply by the -5, which is +5. I put it under this -7, right? And then I add the 2. What do I get? -2. And now I'm done because there's no other numbers over here, is there? Okay, now, this very last number, that's your remainder. I have a remainder in this case when I did my synthetic division. Well, so be it. You're like, yeah, but how do you get your answer? Here's how you get the answer. I need you to think of two ways of thinking about this, okay? This was a third-degree polynomial, correct? You divided by a first-degree polynomial, didn't you? Does division build things up or cut things down? It cuts things down. So if I had a third-degree polynomial and I divided by a first-degree polynomial, that means my answer should be a second-degree polynomial. Got it? Third degree, I cut it down by 1 degree, it gives me a second degree, which means this number, the very first number I dropped, is my x squared. This number is my x to the first, and this is my constant. Another way to write your answer is this. Just like up here, the -7 was the constant, power of 1, power of 2, power of 3. Same thing. This number on the right is your constant, power of 1, power of 2. So my answer is x squared plus x minus 1, but then I have this remainder, don't I? And this remainder is -2 over x plus 5 because that's what I was actually dividing by. Are you with me? Okay, hang in there. I got another one of these. Let's see if it becomes a little bit clearer to you in case it's not. Let's look at the second problem for synthetic division. So, one of the first things you have to make certain of is that what you're dividing by, right, or pardon me, what you're dividing into is in descending order. Is it? Yes, it is. Do I have any missing variables? No, I don't. So that's good. Got it? Okay. So we're going to set up our synthetic division. And remember, this area right here is where what you're dividing into goes. But remember, it's like a shorthand. There's no variables. It's just the numbers. So we already decided this was in descending order with no missing x's. So let's write it down then. I'm going to have a 1 for the x to the third, a minus 7, a minus 13, and a positive 5. Agreed? Okay. Now, this x minus 2 is the outside, isn't it? But how do I figure out what goes on the outside? I take x minus 2 and I set it equal to 0, which means the number I'm putting outside is the positive 2. I'm dividing by this positive 2. With me? Okay. Now, how do you start? Now that everything's set up, how do you start? Good. You take the first number and you drop it down. That's how you always start. Always. With me? Okay. So now, this is the answer spot, remember. So once you put a number in the answer spot, what do you do next? You multiply by what's on the outside. So what's 1 times 2? 2. Where do I put it? Good. Under the next number. Do I subtract? No, you don't, because you changed this negative 2 basically to a positive 2. So you already took care of the subtraction. So all you have to do is negative 7 plus 2, which is negative 5. Excellent. Once you put a number in the answer spot, what do you do next? You multiply by what's on the outside. So what's negative 5 times 2? Good. Negative 10. What do you get? Yeah, you add them together and I get a negative 23. Well, that's just lovely. Then what? Good. I take my number I just put in the answer spot and multiply by the 2, which gives me, negative 46, which goes under the very next number. And then I just do 5 plus a negative 46, which is negative 41. And since there's no other numbers here, I'm done with that, aren't I? Okay, so what's this last number represent? Excellent, that's your remainder. So, this answer spot is a polynomial to what power? Some of you said it, some of you are like, I'm not sure. Remember, you took a third degree polynomial and divided it by a first degree, which means this polynomial down here that you need to rewrite is to what power? Good, the second power, because 3 cut down by 1 is 2. Good? So that's going to be a 1x squared minus 5x minus 23, minus 41 divided by x minus 2, because you're still trying to divide by x minus 2, but it wasn't going in evenly. Does this make sense? How are we doing? Okay, I got another one for us. All right, so let's look at this last one. Synthetic division, right? So, I have to make sure that what I'm dividing into is in descending order. Is it? Good. Is it missing any terms? Oh yeah, it is. So hang in there. So let's get this set up. So it starts out with the 9 next to the 5th, so I'm going to write the 9. And then it goes to 6x to the 4th, so I'm going to write the 6. And after the 4th power should come the 3rd power. Do you see a 3rd power? Neither do I, so what are we going to do? Yeah, you're going to write 0. 0x to the third. After x to the third comes x to the second, which I have, that's minus 6. After the x to the second comes x to the first, which is minus 4. And then I should have a constant, which I don't have, so that's 0. With me? Now, as I mentioned, here's what synthetic division actually sees. It knows this very last number should be the constant. So that has no x's. The number to its left, x to the first. The next to the left is x to the second. The next to the left is x to the third. The next one, x to the fourth. The next one, x to the fifth. Are you with me? If you remember, in the long division lecture that I had done, when we missed a variable, we put 0 in as a placeholder. Well, in long division, that's optional. But in synthetic division, that's not optional. You must put it in there because synthetic division will use it. Long division, it doesn't always use the placeholders, but synthetic division will always use the placeholders, so you must put them in. With me? Okay. Now, how do I get this number on the outside? Well, first off, I have to make sure this is a first degree. Is it? Good. And then I take this and I set it equal to 0. So I have got to do 3x plus 2 equaling 0. And as I solve for x, I'm noticing I get a fraction. Well, so be it. Negative 2/3 is what I'm dividing by. You're like, no, fractions! You can handle it. Trust me, it ain't going to be so bad. With me? Okay. So, how do we get started? Good, that first number always comes down, so I'm bringing the 9 down. And then what do you do when you put the number in the answer spot? You multiply by the outside. So I got to do 9 times negative 2 over 3. So you guys work that out. Stay off the calculators. Come on. Yeah, that's negative 18 over 3, which is negative 6. I put it under the next number, and I do 6 plus negative 6, which is 0. Well, so be it. I get 0, I get 0. Yay! Once you put a number in the answer spot, you multiply by the outside, don't you? Well, what's 0 times negative 2/3? 0. Add those, I get 0. Hey, this ain't so bad so far, right? 0 times negative 2/3? 0. Negative 6 plus 0? Negative 6. And now you got to do negative 6 times negative 2/3, don't you? Okay, you guys stay off the calculators. You guys multiply those fractions. Yeah, that's negative or positive 12 over 3, which is what? 4. Which I add those gives me 0. And then 0 times negative 2/3 is 0 and then 0. Right? Hey, this problem wasn't as bad as it looked. Yay! This last number, that's the remainder. In this case, do I have a remainder? Nope. Now I got to interpret all these numbers down here. So let's look. I've got a 5th degree polynomial divided by a 1st degree polynomial. So 5th degree divided by a 1st degree, 4th degree. So this 9 is the coefficient of x to the 4th, isn't it? What's that 0? X to the 3rd. I don't have any. What's that one? X squared. I don't have any. What's that one? Yeah, that's a negative 6x squared, isn't it? That one, x to the 1st. Don't have any. And no remainders. Here is your answer to this long division problem. Cool? Awesome. Actually, this synthetic division problem. Okay, so if you need to, pause the video, rewind it, go back, listen to the 3 examples I gave you to make certain you understand how to handle synthetic division. And then you guys have fun with this stuff, and I'll catch you on the flip side.